Yesterday we were discussing about linked list, right? So the difference between linked list and I think you are watching on mobile. Please mute your audio, Yashwant. So yesterday we were discussing about linked list and arrays. The difference, there is not much difference in their implementation theoretically. Practically, memory wise, the way the elements are stored, the data items are stored in a linked list and array list will differ. But while writing a program, we don't find any much difference. So this is what I was telling you yesterday. So we'll see with an example program. So I'm defining a class called linked list demo. Main method is defined in it, and we need to use that linked list class. Okay. So the type of item elements that we are going to store in this are of type string. So we are declaring it as a string within the angular brackets, and the name of the object for linked list is given as L1. Then in the constructor, we are leaving it blank. So we are using a blank constructor. So that means you are going to create a empty linked list. Then to add elements to the linked list, just simply use the same add method that we used in array list. So in whichever order you add these elements, in that order they will be added to the linked list. So first I'm adding F, then B, then D, E. Then you have some additional method in add. You have add last and add first, because linked list will allow you to add elements either at the beginning of the linked list or at the ending of the linked list, right? Apart from the add method that we use in array list, we can use add last and add first method. So add last will add the element that you are passing as parameter at the end of the linked list, and add first will add at the beginning of the linked list. And you can also add by specifying a index also, just like we did in array list. Fine. Whichever index you want to add the element at, you can add specify that index as first parameter, and second parameter must be the element that you want to add. So you can use the same operations that you perform in array list, except that you have additionally two methods we used here: add last and add first, which will be useful for adding at the beginning and at the ending of the linked list. So normally a linked list data structure will be operated in the same manner, but the only thing is linked list will have the first element that we have add. Say for example, now after adding a here, this will be at the beginning, right? So this element a, or this item a, along with this item a, there will be some address pointing to the second element, next element. So what will be the next element if it is at index 0? Maybe this will be at index 1. But because we have added A2 at 1, so after A we will get A2. So A2's address will be available at this position. Similarly, A2 also will store, along with A2, it will also store address for the next element, that is F. Similarly, F will store address of B also to point to the B. So that in that way there will be a link between one element and the next element. So first element will have a link to the second element. Second element will have a link to the third element. So in each and every node, we call that item stored along with the address as a node, right? So I'll mention here by taking another notepad window. So a linked list contains nodes. Okay? Each node stores an item, and additionally points to the next node. So you can think of nodes as like this. This can be one node. This can be another node. So you will have nodes like this. So each and every node will store two things. First thing, the actual data that we want to store in that node. Second is it will have a pointer pointing to the next node. So here in this you will store both the element as well as the address for pointing to the second element. So in that way you will have nodes. So each of this box is called as a node here. Okay. So this is how linked list work. But when we are writing the program here in Java, we will not know about all these things. Everything will be hidden for us, abstracted for us, right? We just need to know what methods to use to add a new element to the new node to the linked list, right? And which method to use remove an element from the list, and which method to use to add an element at the beginning or to add the element at the ending or in between. So in that way, we have some methods. We need to know only those methods. The rest everything will be taken care by the ready-made architecture provided to us by the collection framework. So we need not worry about all those operations, storing the address and all. So if this is if you have to implement this linked list in C programming, how do you do? You will write the code for storing the address and everything, right? You will create a structure, and a structure will be representing a node, and in that structure you create an element pointer pointing to the next node's address. So everything manually you need to do, but because Java's collection framework provides us with the ready-made architecture, we need not do all these things. So only thing is how many elements we want to add to that linked list. That many times we need to make a call to the add method. And if you want to add continuously some 100 elements or like that, you can put it in a for loop. You can iterate that for loop, and during every iteration you can add a new element to that for loop. So in that way you just need to know the methods used to add and methods used to remove an element from the node linked list. All these things you need to know. So just like we have add method to add, we have a remove method. We have seen this even in array list, right? And to display the contents of the list, simply use that list name in the system.out.println. That will display all the list elements, just like we did for array list. Then to remove an element, you can either specify the name of the element or the index of the element. So both will work. So just like we did with the array list. Then after removing, you can display the content. Then just like you have add first and add last methods, you have remove first and remove last also. So you can delete an element from the beginning of the list or from the end of the list. And similarly, you have get method. We have used get method in yesterday's program in array list, right? So if you want to get a value, retrieve a single value from a specified index, you can use a get method. And then to set, you also have set method. If you want to create a new value, uh, you can set that using a set method, because you have to specify the index where you want to set the value, and pass the second parameter whatever value you want to pass. So here I stored a string variable here in val variable. By retrieving it from index 2, I'm storing the result in val. The same val again I'm putting it at index 2. Okay, and concatenating with another string additionally changed. Similarly, I'm adding again one more element using add method at index 3. So this is now M. Okay. So did we store already M here? No, we are storing once again here. So you can also store duplicate values also here also. So let me run this program. The original contents are A2, F, B, D, E, C, Z. So we have deleted some elements later. So what are the elements we deleted? The first will have A, then A2, then F, B, D, E, C, and Z. Right? A2, F, B, D, E, C, and Z. Then after this, we are displaying this element. So we have seen that output. Then we are removing F and index 2. So index 2 means what? At index 0, you have A. At index 1, you have A2. Index 2, you have F. Right? So that means A2, F is deleted. After F is deleted, B will come to index 2. So again, if you call remove method and pass 2, then B also will be deleted. So both F and B are deleted. So the resultant will have A2, D, E, C, Z. Then we are removing first and last. So what is the first and last? A is the first one, Z is the last one. So both are removed. So after that, you display A2, D, E, and C. Then you are getting the value at 2. So what is at 2? This is 0, 1, and 2. What is the value at 2? E. Right? Then what I am doing? I am setting the value at index 2 to a new value. So this will replace. Right? So previously you have E and A to D. After instead of E, you have E changed. And then MC. We have added M also, right? So you will get M also. So where did we add M? At 3. So index 3. Before C, you will get M. And after that C. So everything is same as a array list. To look at the output and the way you write the program, is everything similar to that of array list, but internal representation will be different, that memory wise, but that the user or the programmer will not be able to notice that difference, because he just have to know how to operate this program. That's it. He need not know how the execution will take place, on how the memory will be storing these elements, and where it will be storing, whether it is storing continuously or randomly. So that doesn't matter for the program. Fine. Even when you display the list also, so look at the square brackets. It happened even for the same. It was same for even array list also, right? So not much difference in the way you write the program. Only thing is, instead of using array list, you have to use a linked list. Even instead of string also, you can use integer, just like we did for array list. right? Same thing you can use even here also. So next is I'll show you a list. So linked list, array list, all these will be implementing another interface called list interface, right? So we can use the help of list interface also to create either array list or linked list. So we know the concept of interfaces. Interfaces do not have actually concrete methods; they have only abstract methods. But some or the other class will be implementing that interface. So when you're creating an object for a class which implements that interface, instead of creating an object for that class, we can create a reference variable for that interface which is implemented by the class, and assign that in a reference variable of interface with the object of the class which implements that interface like this. So look at this program. We are creating a class called list demo, and in the main method I'm creating a reference variable for list. Instead of using linked list or array list, I'm using list interface. List is actually interface. An interface cannot be instantiated actually, because it only contains abstract methods, right? So I'm specifying integer as its type of values that it is going to store. The reference variable is given L1. And look at the right hand side of the assignment operator. After new operator, instead of using list, I'm using array list, because you cannot use list constructor. Interface will not have a constructor. So, because array list implements list interface, array list will implement list interface. So I can instantiate array list class instead of list interface, and assign that object that is created for this array list class to the reference variable L1, which is of type list interface. This is permitted in Java because I'll show you with an example. In the normal programs we have done, you can create an interface like this. Interface say A, and then we can define a class B implements A. We can define a class like this. Then in another class C, where you define the main method, so here you can declare, instead of creating an object for class B, you can create a reference variable for interface A like this. A is equal to new B. So I don't know whether you remember or not. We have done this when we are dealing with interfaces. So B is actually a class. So B has a constructor. We'll have a constructor, default constructor at least. So here what we are doing here is we are creating an object for class B, but that object is stored in which type of variable? Class interface A type of variable, not the class B type of variable. So generally we do it like this, right? We create a variable object like this. B is equal to this one. Instead of doing that way, you can do this way also. Using this object here now, you can access any methods that are defined in class B. Okay? The same thing we are doing here in list, because array list is a class which implements list interface. Okay, it directly does not implement list interface, but it will implement a class, an interface called abstract list, and abstract list is a sub interface for list interface, right? So that means array list also will implement list methods. So you can do that way also. So the type of data that is going to be stored is integer, not strings. In this example, we have taken integer. First, using this list L1, I'm calling add method, and at index 0, I'm adding integer value 1. At index 1, I'm adding integer value 2. Then when you display this L1, it will display 1 comma 2 like this. Then I'm creating another list, this time L2. Earlier we created L1, right? Now we are creating L2 in the same way that we created here. Here also I'm creating in the same way, but this is another list L2. And for L2 I'm adding 1, 2, 3. So I'm not specifying index, directly I'm adding 1, 2, 3. So the first element will be 1, second element will be 2, and third element will be 3. Then here I'm calling another version of add method which we didn't use in the previous array list or linked list program. So there is another version of add method called add all method, right? So this add all method, what it does is, if you specify an index as a first parameter, and then as a second parameter you specify another list. So we created L2 list, right? So I'm passing L2 as second parameter and mentioning index as 1. So starting from index 1, whatever elements are there in L2, they'll be inserted in between. So what is there at index 1 for L1? I'm calling this add method using L1, right? So L1 dot add. So to which list this L2 items will be added to L1 list. So already L1 has 1 at 0 and 2 at 1. So this 2 will be shifted to the right, and all the elements which are there in L2 will be placed at index 1, 2 and 3, right? So you will get after 1 again 1, 2, 3 you will get, and after that what is there remaining? 2 will be there, right? So when you display them, the elements will be displayed in that manner. So you can and you can insert an entire another list, second list in another list. అంటే ఒక లిస్ట్ లో ఇంకో లిస్ట్ లో ఉన్న ఎలిమెంట్స్ అన్నిటిని తీసుకొచ్చి ఇన్సర్ట్ చేస్తుంది. Then using the remove method, I'm calling remove method and passing index 1. So element at index 1 will be removed. Then it will display this element like this. Then using get method, I'm getting the value at index 3. Then to replace, I'm calling set method. At index 0, I'm replacing with a new value 5. Then after that, I'm displaying. So nothing difference here you find. I'm using the same array list program, but instead of creating a reference variable or object for array list class, I'm creating a reference variable for list interface and assigning that reference variable for list interface array list. So you can assign anything. You can even do a linked list also. You can create a reference variable for list and assign it with linked list. Instead of array list, you can also include linked list also. So you do that program as practice for you. So I just want to show that you can implement this linked list and array list also using this list interface reference variable list. So I just want to show you that one. So for practice purpose, instead of using array list, you can take linked list and perform all the other operations that we did in linked list program. Okay. So
Okay.
let me run this program and show. Progress message. See, first what we are doing is we are adding 1 and 2. Then we are displaying the list like this. So we'll get 1, 2. Yes, right. Then later what I'm doing is I'm creating another list L2. So L2 will have 1, 2, 3, right? So we are not displaying that L2 directly here. So then we are adding for L1 all the L2 elements starting from index 1. So already L1 has 1 at index 0, 2 at index 1. So this 2 will be shifted, and in between this 1 and 2 all the elements of L2 will be added. So what are the elements of L2? 1, 2, 3. So after 1 again you will get 1, 2, 3, comma 2. So see, after 1 you got 1, 2, 3 and again 2. Then you are removing from index 1. So what is there at index 1? 1 is there. So that 1 will be removed. So we will be having 1, 2, 3, 2. Then you are getting the date item stored at index 3. What is there at index 3? 0, 1, 2, 3, 2. So 2 will be displayed. Then later you are replacing at index 0 whatever element is there, you are replacing it with 5. So what is there at index 0? 1. So 1 will be replaced with 5. So you'll have 5, 2, 3, 2, right? So you can use, instead of array list here, you can use also linked list. So here also you have to change it to linked list. So that is a practice for you. You can practice. So this is about list based classes, that is array list and linked list, along with list interface. So next thing is we'll go for hash set or hash maps. See, first we'll see hash maps. The hash map is similar to associative arrays in PHP. You must have learned associative arrays in PHP, right? So associative arrays will have key value pairs. Associative arrays, right? So do they have? They have key value pairs. So elements are stored in an associative array in the form of key value pairs. So this key will act like an index of an array, and value will be the actual value stored in that array. So generally in normal array, index will be a numerical value, integer value, starting from 0. But instead of that index being a numeric integer value, if you can take string value, then that will become a key. We can call that as a key, and whatever value is stored at that, so we simply call it as a value. So totally we call it as a key value pairs. So hash map also contains the same thing. A hash map also contains same thing. So, and as a value, you can have both strings as well as numeric values. It is up to you. But key will definitely be a string value. So it is similar to dictionary in Python and associative arrays in PHP. So Java provides us with this kind of mechanism by using something called hash map. So let me show you an example program. So you need to import a hash map, or if you are importing the complete util package, then that is very well and good. So along with hash map you need to implement a map also, right? So these are predefined classes and interfaces, so you need to import both these things. So why I'm writing this is because hash map and map has some link. We need to import both these things, right? If you simply import util package, you will not know that there is a link between hash map and map, right? So what are these means? Interface and classes. So what I'm doing is, so you observe, if you have an object created like this, At the constructor, you'll have same name, and class name also is same. It is nothing but a class. Just like list and linked list and array list. List is an interface, and linked list and array list are classes. So array list and linked list both implement the list interface. So similarly, hash map is a class which will implement map interface. Right? So we need both of them, map interface as well as hash map interface. Earlier in the previous programs, what we have done is we have directly imported util package, which will import all of these things: list, array list, abstract list, linked list. Everything will be imported. Similarly, you can do that here also. But to make you know that this map is an interface and this is implemented by class called hashmap class. So I'm specifically importing these two class and interface together in the two different import statements. So I'm defining a class called hash maps. Why I've given hash maps? Because if I give hash map, it will generate an error because hash map is already a predefined class. So I cannot use the same name for user defined class. So I'm giving hash maps. Then in the main method, I'm creating a collection for hash map with its name as runs. Right. So because hash map is a key value pair and you have a key as one data type called string, it must always be string, and value can be either integer or string. It is up to you. It is our programmer's optional, right? But key must be definitely a string. So because we require to store both key and value, we need to specify the data type of key as well as value. Earlier in array list and linked list, we didn't specify the index type, right? Because by default, the index type will be a numeric value, that is 0, starting from 0. For hash map, it is not like that. So the data type of the key must also be specified. So how to specify both the data types means use the same angular brackets, open and close. The first one, what you specify is related to the key. Second one is related to the value, right? So I'm using string for key and integer for value. So you need to do the same thing here. So I'm using a blank constructor. Then I'm printing this runs. Because this is empty, it will not print anything, right? Then here, instead of add method, we have a method called put method. This put method will add a new key value pair, right? So to add a new key value pair, what you need to do is you have to make a call to put method. This will receive two parameters. First one is the key and second one is the value. So key must be exactly what type of value you have mentioned here, string. So that must be mentioned here, Kohli. So I'm giving Kohli within double quotes because it is a string, comma, and because the second parameter must be an integer value because we declared it as integer, the value. So you need to give 10, right? So similarly, I'm giving runs dot put Rohit 30 and runs dot put Rahul 20. Then I'm printing size of runs, right? So you have the same size method. You can call that size method to find the size of the hash map. How many elements are there you want to know, then you can call the size method. Then I'm printing runs. Then we have two methods called contains key or contains value. You can use this contains key method to find whether in a hash map there is a key with its name, say specified as Rohit. If it is there, then it will return true. Otherwise, it will return false, right? So this is a new method which you don't find in array list and all these things, right? So what is this contains key method going to do is it is going to check whether uh, this list runs has a key, whether it contains a key with its name passed as parameter in the form of a string for this method. So I'm passing Rohit. So it will check whether there is a key with its name Rohit or not. So if it is there, it will return true, otherwise it will return false. So if it returns true, then this if statement will become true. As a result, this if block gets executed. And inside this if block, what I am doing is uh, I'm declaring a integer object a, right? Because I'm calling a get method. So just like get method is there and set method is there for linked list and array list, you can also use get method here also. So I'm calling runs.get of Rohit. So what is this going to do? It is going to return the value stored for Rohit. What is the value stored? 30. And what type of value is it? It is an object of integer class. So we need a reference variable for integer class to store. So you need to declare integer a. You cannot give simply int keyword because that will become a primitive data type variable. But what type of value we can store in a collection? We can store only objects. We cannot store primitive values. So this will return a primitive, it will return a integer object. So that will be stored in A. Then I'm printing value for key Rohit is plus. Then runs.clear method, what is it going to do? It is going to clear all the elements of the hash map, right? Then I'm making a call to a method called print method. I've defined that print method at the bottom here, public static void print, because you have only main method in this class. And if you want to make a call to this print method from the main method, even this print method also must be a static method, because uh, main can call only other static methods in the same class. So I'm defining this also as public static void print. And for this, what I'm doing is I'm passing as parameter entire hash map, right? So here, what I need to specify as parameter hash map type of object, right? Because runs is what type of object it is, hash map class type. But because HashMap implements map interface, you can create a reference variable of map and store that HashMap object in that reference variable of map, just like we did in the previous program. In the reference variable for list interface, we are storing object of array list class. So in the same way, you can store HashMap object in map interface reference variable. So what I'm doing here is I'm using map interface reference variable here. I'm specifying the data type string integer uh, followed by runs, right? So this object runs is passed here as parameter to this print method. So now again I can use this runs method in this method also, runs object here also. So if runs dot is empty method will return if that hash map is empty, it will return true, otherwise it will return false. At least one element is there, it will return false. If no elements are there, it will return true. Because earlier we have called the clear method, what will be there in runs hash map? Nothing will be there. So I'm calling whether it is empty or not. If it is empty, then this will display runs is empty. Else it will display whatever values are there in runs. Those values will be displayed. Okay. So let us run this program and see the output. As name we have given as maps. First, the main method gets executed, and we have created a runs hash map, but we didn't assign any value for that one. right? So when you print runs, what is it going to display? It is not going to display anything. Runs is empty, right? Then what we are doing, we are adding three elements: Kohli 10, Rohit 30, Rahul 20, and size of runs we are displaying. Size of runs is displayed 3. And then when you print runs, what is it going to do? It is going to print a hash map like this. For a linked list and array list, we have square brackets, right? But for this hash map, you will have a brace. Even in Python also, for dictionary also, you will get the same symbol. Brace will be within the braces, it will be displayed. So brace is open. First key is Rahul and its value is 20. Second key is Kohli and its value is 10. And third key is again uh, Rohit and its value is 30. Then what you are doing is you are checking whether uh, the hash map contains Rohit key or not. If it is there, then you are retrieving the value associated with Rohit and storing it in A and displaying that using this, right? So what value for key Rohit is 30. Then we are making a call to clear method. Then when you print runs method, what is it printing? Runs is empty. So why it is printing empty means because you are making a call to print method, right? So first when I call print method here, print method will check whether uh, by calling isEmpty method whether the runs hash map is empty or not. If it is empty, it will display this one. Otherwise, it will display whatever values are there, right? So when did I call print? Soon after I created hash map. Here I immediately made a call to print method. So because this is not having any value stored in it, it is an empty hash map. So this will return what runs is empty. Then after adding that, if I make a call to print runs, what is it printing? Whatever values are there that it is printing, right? So finally, what I have done, again I call print method after clearing. So this will again display runs is empty. Okay. So this is how you can implement hash maps. You can create any kind of hash map, string integer and string double. You can store double values. You can store even string values also, right? Anything you can store. Is that okay, Yashwant?
ఎస్ సార్. ఒకసారి హ్యాష్ మ్యాప్ ట్రై చేస్తాను సార్. డౌట్ ఉంటే రేపు అడుగుతాను.
Yeah, sure. Okay, so we'll meet
ఓకే సార్.
tomorrow.
ఓకే సార్.